The next speaker is Vasil Monchev. Are you here? Vasil? Okay, we can see your screen.
I hope you can hear me and see me now.
Yes, perfect. Okay.
Okay.
So it's from strings to strings with GraphDB mapping UI.
Yeah, thank you, Sebastian. So I'll give you a very short presentation how we basically develop our knowledge graphs. And yeah, this is the title of the presentation, String to Things, which is one of the most common problems we face. My name is Vasil Monchev and I'm the CTO of Ontotext. The presentation is really a short one, and then we are going to have a demo. I will give you a bit of introduction of who are we and how we see the value of the semantic technology, and then obviously give you some concrete examples. What are the common challenges of building knowledge graphs? This is exactly how we really develop them. And lastly but not least, we'll give you some free tooling which you can use in your projects. It's completely free on top of GraphDB free, and this will be the demonstration. So I'll not spend a lot of time because I hope most of the people here knows us, but we are one of the semantic web pioneers, and we started like in the early 2000. Now we are part of Sirma Group, which is really the biggest company listed on the Bulgarian Stock Exchange. We have 70 persons, and we have invested a massive uh, investment in research and development. Uh, our business is mostly we are a global player in multiple knowledge intensive industries like life sciences, healthcare, financial industry, and we are collaborating very actively with the research community and all these certain type of industry bodies or uh, communities and the research. I'm really very thankful to DBpedia because definitely because of DBpedia, the state of the semantic community is what we currently have. So I'll give you what's our perspective of the added value speaking with a lot of big businesses. And the RTF is not really only about graphs like many people see. This is about shared meaning between different type of concepts where the humans can agree or what is the ontology, what is the scheme of the information, like classes, naming them consistently the classes, the properties, and all, not just the instance data. And this is what makes this technology highly powerful. So if you see this type of a diagram, it lists what is really a one terminology. And for the human reader, also for the computer, it will take really, it will be self-explainable. Basically, you can find out some economic cooperation that this is a cost term, it has some preferred label, you know how to reference every different node, you know that there are some more specific concepts, and this is really a big power because we see no other format or technology which will allow you to implement something like this. Having said this, this is one of also the biggest challenges, how to produce high quality knowledge graphs, RDF models, ontologies, because you need to agree over many different type of aspects of these knowledge graphs. And this could be quite challenging if you really do everything from scratch without not the proper tooling to do so. So what is the typical use case and solution we develop? This is a semi-fictional use case, like there is a knowledge graph case where a US company want to develop a knowledge graph about US financial institutions. And typically the normal way how you start with these demos and POCs is that you start with Wikipedia, DBpedia. This is an excellent starting point because you have a really huge coverage of public information which is available, and it's really free. This is the best thing. Sadly, one of the biggest challenges working with Wikipedia and DBpedia is that it lacks really highly specialized knowledge. And this is not what these type of sources are optimized. Basically, they give you a very good starting point, but once you really want to explore and develop some commercial, you need to complement this with commercial or private for the client data sets in order to integrate them. And the commercial data sets are very good in their consistency, details, they have much higher quality, but they have one big disadvantage. They lack really common knowledge about locations, cities, countries, And what is really very well covered in DBpedia, and this is really one of the big challenges we want to solve, how you can combine the two data sets, reuse the schema of the DBpedia and Wikipedia, and integrate quickly and efficiently some private data for the client. So yeah, this is what we are going to discuss now. And what are the common challenges we find is that typing the correct identifiers is always quite tricky. It's not easy to remember what is a core border. You know that this is a wonk namespace, and that could be very easy to misspell this. Prefixes really, they solve part of this challenge, but you have to know what is COS, what is COS extended language. And choosing the right identifier, what is the actual meaning, can be quite inefficient. So the Dublin core lists like 55 predicates, and FIBO contains thousands and thousands of classes. And if you go to DBpedia, it's really even bigger. So, and also the other challenge is, if you ask when you are developing these knowledge graphs, can you tell me what is the difference between the Dublin core source or provenance? Obviously, you need to open the schema ontology in order to find out what is it. And there are some dangling identifiers. The dangling identifiers is once you connect two different knowledge graphs, they're syntactically correct, but you see that there are many ways how you can misspell this. On this type, if you have HTTPS, on other we have uh, other ways to reference the namespaces, and it becomes very quickly a mess how you can do this. So the question here is, what is the tooling in order to optimize this process? And this is what I'm going to show you. You're going to see one of the mapping interfaces, which is new to GraphDB 9.4. And there are two types of workflows. One is the interactive, where the user fully controls the process, and the other is the batch mode, where you can script things and run them in the night. So the typical flow is you start with a structured file. This is what the client gives you as an Excel file or some CSV. You load this, and GraphDB integrates Open Refine, and you can do some data cleaning. Reconciliation is how you map strings to things. You choose the right one from the reference data source. Then using the RDF mapping UI, you can quickly decide how to make this as a valid RDF model. And later on, you can export this and uh, generate a valid RDF. So this is what I'm going to say and show you. This is a vanilla GraphDB installation. This is the GraphDB free service. I'm going just to create a new repository, which is like my project. So the very first thing what we want to do typically is I have prepared some models to which I want to align the data. And currently we have the DBpedia ontology and the FIBO models, which we want to complement to use the not specific data from DBpedia and to add the highly specialized knowledge from DBpedia. So we select the import, and we import the DBpedia in a name graph. And we say this is DBpedia. This makes very easy to update the data later on. So we are going to update this data and add it to its own name graph. We are going to do the same thing with the FIBO. As you can see, I have just dumped the FIBO ontology with all its extensions in a directory, and I haven't bothered to clean up the XML files. So the server will automatically for me just find what are the correct files to import, and we will ignore the rest. I'm just typing in anything which will allow me to really update the data later on easily. So while the updates are running, I just want to go to my repository and enable my autocomplete indexes, which will make the interfaces to consume all the types which are loaded into the model. Okay, so now the next step is really to add the data and to give some hints to the database how we should parse it. And I'm going to choose just one file, National Bank. This is really one of the use cases which want. This file is distributed by the US Federal Reserve, and it contains some financial institutions, where is the city, the state where they are, and their certificates around there organized, and the RSSID. RSSID is a very complex important identifier for this use case. This is really a unique identifier assigned by the Federal Reserve, which differentiate the different bank institutions. So if we go back here, we will see that there are some American National Bank is actually a combination of multiple banks because they were chartered in different jurisdictions in the different states. And this is quite different from the way how in DBpedia everything is modeled, where there is only a single bank. But for any subject matter expert, they want to see this type of jurisdictions and how they were chartered, this type of banks. So the idea is really how we can add this information and make it available next to the DBpedia model so we can enrich it and enable new type of use cases. The refined interface parses the data, and you might see it has automatically refined all the data and it's a tabular format. Typically, the first thing when I get any Excel or external data is to check for the data quality. Although this is a file generated by the Federal Reserve, if you do some sort of textual facets, we will find that some of the states are duplicated. A very common reason, even I don't see why I'm not even checking this, is that there are some not trimmed values. So I'm going to trim them, and now we see that there is some consistency in the values and they all perfectly unified. The next thing is about the cities. The cities typically come in the way they were suggested by the people who apply the documents, and obviously they don't use any reference data or semantics, so everybody types them in the way they want to see, how they believe they should be typed. So there is no agreement. So one of the ways how we can do some sort of a transformation is to go to the clustering, and depending on the various algorithms, we can decide how we want to cluster. And you see it here, sandwich is written 2 times. One is with the dot, the other is with out dot. The MacLean has different spelling, and Crystal Lake has a different order. There are different algorithms, like if you can make it phonetically to cluster things which sounds similar, but for this case, we are just going to select all the cases and say cluster them in order to clean up the data. So far, this is the simple cleanup, and everybody will say, okay, this is done. We have some trust. Now, the complex part is how these strings and numbers to convert them in a useful schema, which can become a correct part of the linked data open cloud. And I'll give you the reconciliation process like you saw on the diagram. This is really to submit the strings and to try to convert them to things. GraphDB comes with some standard public services, which is about Wikidata. It's relatively easy to implement your own service. This is a public service. I hope that it will work. So the process of reconciling is to get the first 100 values and to submit them to the reconciliation service. Currently, this works against Wikidata. So in this case, this will suggest you some different types, which looks similar to this column. For now, we are not using any contextual information, and this contextual information will be very useful if we want to have the cities. For example, look up cities only in some specific administrative regions. For the sake of this demo, I'm going just to use the state of the United States, which seems very similar. I know that this is not a chemical element, so I start the reconciliation process. The reconciliation process checks against the graph and finds out identifier which is suitable. As I said, this is a public service which is supported by Wikidata. You can easily implement your own. So there are some constraints on the throughput. You see that this is not the fastest process. Let's wait a few more seconds. If you're very impatient, you can switch to GraphDB and go to another mode in order to do the RDF mapping process. But let's see the reconciliation process and wait for the results. And this is where the complex part really starts once you start with the knowledge modeling, whether how the people agree over the different identifiers, because this gives the biggest added value of the semantic technology. Okay, so we're just almost there. And we got a new column which says that the service reliably, because I say to select the biggest and the best match to be automatically selected, it notes now that this is the Ohio state, and this is reconciled against Wikidata, which has links to Wikipedia, and then respectively we can find what is the relevant DBpedia entity. But there are two types of states which were not reconciled. For some reason, the DC was not identified as a state, and it suggests some other types like direct current, data center, or whatever. So for the sake of this demo, we are going just to apply the same transformation, and we say, okay, this type of is a new type of a state, and then I will leave it to the knowledge experts arguing why Wikidata is not listing DC as a state, or whether this is a problem with the reconciliation. So what we have now an entry point to the knowledge graph, and we can go to the RDF mapping. So this is the process where we want to say how these values are translated into RDF, and we are going to use the character number. everything is organized around this interface to have easy namespaces. So I'm going to say this is my project, and I will use this as a base prefix because this is how all my prefixes will start. I'll use the chart number and I'll leave it like this. And then I'll type, okay, this is RDF type. And this RDF type, I want to make it to something from FIBO, for instance, because we wanted it. And I'll say, okay, I know that this is something like a financial instrument or financial institution. This interface supports reading the commands of the ontology. So if there are some commands describing in a human readable manner what is this.
But still, you're running into Q&A, okay?
Okay, I'll just quickly skip this, and I'll not put everything here. But the idea was to show how you can do many powerful configurations here. The only thing is really to say a state, and I would say I'll drag this column state, and I'm going to explain how you can get some more interesting values like the cells, and I would say this is the state. We want to get the reconciled value. So this is the recon and best ID, and we are going to get the best IDs, which were the Wikipedia and the Wikidata IDs. So in this column now we have the identifier. Another thing is we can see this in Sparkle, and the database will automatically generate this type of service, and I can see the results which are a valid RDF, and I can just insert it. So okay, and now we are done, and we have transformed the strings to things. Thank you for your time. I just want to point you that this is a completely free product, and Ontotext is a responsible company which helps you grow your business, so you can start with be free, and then you have an easy upgrade path. Thank you for your attention.
Okay, thanks, Vasil. Yeah, so what's the thing? You mentioned something very something which is not so obvious there. So we analyzed a lot the linked data cloud over the last years, and the linked data cloud kind of like contains the long tail of information. Yeah, so basically you would find good identifiers for everything you want to have extended. Yeah, and but Wikipedia and also DBpedia, because it uses Wikipedia, and also Wikidata, they are encyclopedias, and encyclopedias are defined as a summary of knowledge. Yeah, so that's why it's always a bit too coarse-grained to cover 5 banks. So they make it one, right? But in our view, so you're using Wikidata identifiers or the old DBpedia identifiers or anything, but in fact, this is kind of like a bottleneck for linked data, yeah, because I think there are cool identifiers out there, but you just don't find them and you cannot reconcile against them. You know what I mean?
Yes, absolutely. And this is like I would say a business challenge, because the added value of the technology is how you can share meaning, but at the same time, there are many industry players who have their business models about collecting, maintaining these type of data sets. Some of them were open to disclose the identifiers and make them for publicly available, but others forbid you even to reuse them with their licensing terms. So the real challenge here is that you need some easy toolings which would allow you to bring these two worlds, like the encyclopedic knowledge, which is really general purpose knowledge, and every knowledge graph needed. You're not going to invent the states, how they are named, and all their administrative locations or some common public knowledge. But for implementing business case basis, you need really the highly specific data, and the key is really how you reconcile the two models to live into single live knowledge graph. Yeah, I'm totally agree, and this is really the type of a tooling we try to make easier, which I hope will be beneficial to the full community.
Okay, yeah, thank you for your presentation, Vasil.